So good afternoon. Thank you for presentation of my name. My name is Radim CAJKA. It's a Czech pronunciation, but I write it without this hook because it's very terrible to write in English. So I am from Czech Republic, from Technical University of Ostrava, and we prepare with my colleague to this presentation or paper, the experimental verification. Experimental verification of soul foundation interaction. So shortly introduction. It is the task from structural engineering. We have solved some foundation task. It means that the whole structure interact with foundation plate, with foundation box, and sometimes also with foundation raft with piles. And we have to release any forces, any deformation by means of sliding joint. What is the sliding joint? There are some layers between the rigid foundation plate and weak subsoil, and this sliding joint can release this, of course, the deformation and extra stresses, the tensile stresses, which are very dangerous for concrete. And here you can see sorry, I not completely. Yes, okay. The first test, it is laboratory test, and we observe this deformation independence with vertical and horizontal loads. The two asphalt belts are stressed into 3 concrete blocks, and we measure the deformation independent of this vertical horizontal loads, and also on to temperature, because it is very important in this case. So here is the equipment, and where can we use this solution? It is problematic foundation condition. It means landslide areas, low-bearing subsoil. It is very now in undermined areas and mining activities where arise the horizontal and vertical deformation of subsoil, and then arising to big internal forces in the structure. And we can use it in this time also in extremely large foundation structures without joints, because the shrinkage of concrete also arise the tensile stresses. We would like eliminate this rigid contact. We try verified this laboratory test in real on real structures. So interface, we have solved this source structure interaction task. It is the method of calculating the settlements according to Czech standard, which is the same as in Eurocode 2 or Eurocode 7. We have in Czech Republic this correction coefficients, which varied between 0.1 to 0.4. In Eurocode is equal 0.2. It is the same procedure. Here is the experimental program with a small foundation plate. We verified 2 foundation concrete slabs. The dimensions are 2 to 2 meter, heights of 0.15 meter, and the experiments differ in the load character because it is the original subsoil from clay. We have this specialized facility, so-called this stamp. This is a big steel structure, and we pushed the plate in the subsoil by means of this jack, and we try to measure the deformation of the subsoil together with this plate by means the vertical force, and we also can can act of this edge by horizontal load. So here you can see the details. The vertical load can be up to 1,000 kilonewton using a hydraulic press. See, and the equipment is also possible to act by horizontal loads and measure the horizontal deformations. Here you can see the details, but of course the horizontal load can be a little lower than the vertical because it depends on the rigidity of this support by big pile foundation. Here's the results of the first experiment. We applied the vertical load by 75 kilonewton after 30 minutes, because it is very important to have any time for relaxing these deformations. The vertical deformation was observed using 24 displacement sensors until the maximum bearing capacity is reached. And here you can see the number of these sensors. And on the graph right, you can see the duration of the test time and the load on vertical axis. So the maximum was reached is approximately 500 kilonewton. Here are some results in the graph, and also this picture. On the picture, you can see the uplifting the edges of this slab, and also erasing the cracks and decreasing the rigidity of this plate. And here are the result with the deformation and in dependence of these sensors, yes, in various loading steps. The second experiment was performed by means these two horizontal loads, and it was also the combination, of course, the vertical and horizontal load, but the vertical load was only constant, 100 kilonewton, and the horizontal load was applied from one side of this plate. The result of the deformation depending on the test of time of this test, you can see on the right graph. It is in sensor 6 in the middle of this plate. Of course, in the first deformation step during one day, it was the deformation was greater, and then were a little lower. And here the other results. The ambient temperature varies, of course, from 5 to 22 degrees of Celsius, but it can be seen here. And but in the middle and edge of the slab, the temperature was nearly constant, something between 10 and 11 degrees. It means that the constant temperature is not so much dependent on the ambient temperature. And next we applied some this result on the real structure. Here you can see the block of flats which was solved together as a space structure. It means foundation slab together with foundation box, with plate, walls, and together with also the upper structure, all was concrete, the combination of wall, plates, and columns. The situation was a little worse because the foundation condition was not very good, so we have to use this combination with piles, and the area was a little sliding, so it means we also solved the task that we have the longer piles under this shear surface, which increase the stability of this whole structure and foundation area. That's the result, and the result was that the whole stability was, by means this solution was on the same level as before the loading this slope by structure. Here's some result from numerical solution. It was solved by specialized program Plexis, and here you can see also. Here you can see also the cuts in various directions. What is important is to measure or to calculate the distribution of contact stresses between the subsoil or the load distribution and the part which is loaded by these piles. It's not so easy task. We solve it by any iteration method, and here are some results for various stages. It's not so clear, but the contact stresses into slab under the slab foundation is something between 100 to 2000 kilopascal. And here's the real test in situ on the real structure. We measure strain in two piles in 3 vertical levels on pile number 13 and number 21. I show you it is here, this area, and here. So the contact pressure between foundation plate and subsoil in 2 to 3 points nearby piles 13 and 21. It means this block, this and this. So it's nearby for comparison. And we also measure the strain in foundation in X and epsilon direction into center. The measuring was compared with vertical and horizontal geodetic measurement in corners of this reinforced foundation plate, which is sometime between 20 to 30 meters. And the data logger in the middle, you can see these pink wires, and we sample all the data in one data logger. And here's some details of the measuring points. It is the measuring plate for contact stresses, which is located near these piles. And here's the measuring point. It is situated in the middle of the plate because they're arising the big forces. And as you can see, we measure in 2 directions and in 3 levels, on the bottom, in the middle, and nearly on the top of this foundation plate, because these couples can measure not only the strains but also the temperature, and the temperature varies, of course, during the hydration heat and ambient temperatures. So, and some details in the end. What is important? It is some details from drawings, but it is not so clear. But I show only the details here. It is the details of this contact pressure cells, and with this which is connect with these wires about the data logger. And what is also important, you can see the details of the pile and this foundation. As you can see, there is a very it is not rigid connection, but here is this sliding joint, which can reduce this horizontal deformation, of course, and this and due to also this horizontal forces, the walls are, of course, the tensile stresses and tensile forces. So, and some sentence about in the conclusion. We show the example of the conceptual design and static solution of spatial reinforced concrete frames, wall structures, and foundation blocks. And this interaction task was solved by finite element method. The piles, of course, increases the vertical and horizontal load-bearing capacity. We measured this strain into 2 piles and also in nearby in 3 contact stresses in the subsoil. Also, we solve or measure the strain in this foundation plate in 2 directions. And in the end, all measurements are currently ongoing and are continuously evaluated during the construction of the supporting structure, because the structures is in progress now. But the first results show that there is a good agreement between the design, the numerical solution, and also these measurements. So thank you for your attention.